solve a more complicated trig equation, we can use the same techniques that we would use for a non-trig equation. We'd subtract 1 from both sides. And divide both sides by square root of 2. At that point, what you end up with is a basic trig equation. And to solve this, I would draw the xy plane, identify the quadrants where our solutions will be. So in this case, where is sine negative? Sine is negative in quadrant 3 and in quadrant 4. This is a special triangle, so we don't need to use the calculator for this one. The y value, or opposite, is 1, and the hypotenuse is square root of 2. This is representative of a 45, 45, 90 triangle. In radians, that would be a pi over 4, pi over 4, pi over 2 triangle. So we know that the reference angle is pi over 4. Now we need to find the actual angle. The angle measure for the angle in quadrant 3 is represented by pi plus pi over 4, which equals 5 pi over 4. And the angle in quadrant 4 is represented by 2 pi minus pi over 4. Which is 7 pi over 4. To identify all solutions, you would take these two solutions and then add 2 pi k, where k is any integer. We're going to start solving this equation as though sine squared theta was the same as an x squared. At this point, you have sine squared theta is equal to 3 over 4, and sine squared theta is the same thing as sine of theta all squared. And so to cancel out a square, we can take the square root of both sides. Just as if we had had x squared is equal to 3 over 4, we take the square root of both sides, we would end up with x is equal to plus or minus the square root of 3 over the square root of 4, which simplifies to 2. So the trig equation that we want to solve is sine of theta is equal to plus or minus the square root of 3 over 2. If you want, you could separate this as two equations. When is sine of theta equal to positive square root of 3 over 2, and when is sine theta equal to negative square root of 3 over 2. I'll solve it all at the same time. All of these angles will have the exact same reference angle. It's the reference angle that produces a sine value of square root of 3 over 2. This triangle is a special triangle, so we don't need to use the calculator to find the angle. The angle measure, or the reference angle, is pi over 3. There's 4 solutions for this equation, and we can find all 4 using the reference angle of pi over 3. The angle in quadrant 1 is pi over 3. In quadrant 2, it's pi minus pi over 3, or 2 pi over 3. In quadrant 3, it's pi plus pi over 3, which equals 4 pi over 3. And finally, in quadrant 4, it's 2 pi minus the reference angle of pi over 3, which is 5 pi over 3. And these are the 4 solutions. To express all solutions, you could take each angle and add 2 pi k, where k is any integer. But you can also condense the solutions, because there's essentially 2 pairs of solutions that are along the same line. And whenever they're along the same line, you can combine it to just adding pi k. So a condensed way to write the solutions would be to pick one of the solutions. If we start with, let's say, pi over 3, we could add pi k, and that would cover the solutions from the pi over 3 angle and the 4 pi over 3 angle. And then we can choose one of the other solutions. I'll use 2 pi over 3 and add pi k. And that covers all the solutions for 2 pi over 3 and 5 pi over 3. Let's look at a trig equation that's quadratic in form. It's quadratic in form because we have a sine of theta and we have a sine squared of theta. And this is equivalent to having an x and an x squared. For this problem, I'm going to go ahead and make a substitution. Let x equal sine of theta, and then I'll rewrite the equation as 3x squared minus 7x plus 2 equals 0. When you do this kind of substitution, you can solve the equation in the x's and then not even worry about the sines or the trig function at first. So one way to solve this quadratic equation is to factor. Once it's factored, we can set each factor equal to 0, and then we'll solve each of those equations, which leaves x is equal to 1 over 3 and x is equal to 2. If this was not a trig equation, we would be done at this point, but now there is more work because we didn't have an x in our original problem. That actually is representing sine of theta. So the two equations we need to solve at this point is sine of theta is equal to 1 over 3 and sine of theta is equal to 2. When we look at the sine theta equals 1 over 3 first, this is not one of the special triangles. So instead, and the same goes for the sine of theta is equal to 2. So for each one, I'll use the calculator and the inverse sign. Before I use the calculator for sine inverse of 1 over 3, I just want to identify the quadrants. The sine value is positive, and sine is positive in quadrant 1 and quadrant 2. Plugging sine inverse of 1 over 3 into the calculator gives a reference angle of 0.34 radians. Then I can use the reference angle to find the actual angles. The angle in quadrant 1 is the same as the reference angle, which is 0.34 radians. In quadrant 2, to find the approximate answer, I'll plug in pi minus 0.34. to get 2.80 radians. And those are our two solutions in radians on the interval of 0 to 2 pi. We still need to find the other value. So if we plug in sine inverse of 2, this calculator is saying math error. You should get some kind of error message. And the reason you get an error message or undefined is because for the value of sine functions, the answer always needs to be in between -1 and 1. And so the error is indicating that this is not possible, so there's no solution that comes from the equation sine theta is equal to 2. To write all solutions, you would just add 2 pi k to each of the previous solutions. This is another equation where we can use factoring to solve. And we can use factoring because there's two terms and both terms have a tangent theta. If you factor out a tangent theta, that leaves inside the parentheses 3 sine of theta minus 2 is equal to 0. And just like with the previous problem, once it's factored, you can set each factor equal to 0 and solve. Let's first solve the equation sine theta is equal to 2 over 3. Sine is positive in quadrant 1 and quadrant 2. If I fill in the triangles, we have 2 on the opposite side and 3 on the hypotenuse side. This is not one of the special triangles, so we need to plug it into the calculator to get a decimal approximation for the reference angle. The reference angle is approximately 0.73 radians. Therefore, the actual answers are 0.73 radians and 2.41 radians. At this point, we're not done yet because we also need to solve the equation tangent theta is equal to 0. The angle for this is going to be a quadrantal angle. And when it comes to quadrantal angles, you can try to draw a triangle, but I usually prefer to think about the unit circle. And for this, we're just identifying the points that's one unit away from the 0 on the x and y axis in the positive and negative directions. So tangent is opposite over adjacent, which is equivalent to y over x. So we need to find when y over x is equal to 0. This is going to happen whenever y is equal to 0. So we just have to identify the ordered pairs where y is equal to 0. And that happens at 0 radians and pi radians. So those are two more solutions to the original equation. And for the last part, we want to express all solutions, not just solutions between 0 and 2 pi. So for that, we have 0.73 plus 2 pi k, 2.41 plus 2 pi k. And for the tangent solutions, you could say pi plus pi k. Instead, I'm going to write it as starting from 0. It would be 0 plus pi k. But that's actually the same thing as just writing pi k.